In this section, you should understand the functionality of the digital governor system. This configuration drawing shows the DGS 8800E with its associated accessories with bridge command through a remote control system and a control room command from a separate manual lever, which is the normal arrangement for this engine type. The Trafo 001 is a transformer unit that supplies the electric actuator's power amplifier with 135 volts AC for speed control of the electric actuator. The transformer has 220 volts AC, 230 volts AC, or 440 volts AC input, and 135 volts AC output. It is specified to deliver up to 3.6 kVA continuously. 110 volts AC, or another input voltage transformer, may be delivered on request. The panel section allows direct operator control of system functions. The signals from process are all connected to standard terminal boards. The process signals are adapted to digital data through individual plug-in adapters, with options for all standard signal formats. The ABS power unit, SBS servo amplifier, and 24-volt DC power supply for the DGU 8800E are mounted in a cabinet for installation on a wall in the engine control room. The servo amplifier, together with the power unit, is the electric actuator's electronic control and controls the electric actuator's speed. The actuator system is comprised of a brushless servo motor type Parvex LS620EL, ELACT 001, Parvex LS910EW, ELACT 002, or Parvex LS914EM, ELACT 003. With a reduction gear type Cyclo Fabs 25/89, ELACT 001, Fabs 35/59, ELACT 002, or Fabs 45/59, ELACT 003. The servo motor is electromechanical and contains no electronic components. It has ball bearings which are lubricated for life. The system is certified for protection degree IP65, Precision Class N, and Insulation Class F. The servo motor is controlled by servo amplifier Parvex SBS 15/30A, ELACT 001, 002, and Parvex SBS 30/60A, ELACT 003. The servo motor has a built-in brake which activates if a failure such as system failure or power failure occurs, and will keep the fuel rack at the current position, that is, fail-safe condition, as the engine will continue to run at its previous speed. A thermal protection device is also included in the servo motor. The fuel index, or actuator position, is measured with an absolute encoder, mounted directly on the servo motor. The fuel actuator is to be mounted and connected to the fuel rack of the main engine in accordance with drawings issued by the engine builder. The speed pickups are two inductive proximity switches, mounted towards engine flywheel in a waterproof box. Mounting brackets must be properly made to prevent vibrations. Sensing distance to flywheel is 2.5 mm plus minus 0.5 mm. The DGU unit is to be located in the control room console and should be mounted in the vertical section of the console. The Dsu Cabinet is a standard wall-mountable box, which should have less than 50 meters cabling distance from the actuator. The actuator is mounted on the engine and is connected to fuel linkage in accordance with drawings issued by the engine builder. The speed pickup unit is to be mounted towards engine flywheel in accordance with drawings issued by engine builder or NOR control. The RPM reference values are automatically computed for all engine running conditions, such as start, stop, slow down, emergency run, and normal running. The RPM measurements are converted from pulse frequency data to filtered digital internal values. The difference between reference and measurement is processed to ensure the optimum correction signal to the fuel setting, taking both the loading characteristics and running RPM into account. Maximum fuel is automatically limited according to tolerances given by speed and scavenge air, scav air, pressure. Adjustable servo PI controller. Output scaling for signal adaptation to the motor servo amplifier. Controlled signal monitoring, in case of failure, blocks the actuator. Distribute fuel indication to user. Options. The DGU performs other tasks than regulating the fuel to the engine. The VIT function and the LCD lubrication are two of these functions. Variable injection timing, VIT. This function is made in accordance with MAN, B and W. The three input signals used by this function are NR equals measured engine speed from DGU. PSC, ABS, equals absolute scav air pressure equals 1 bar plus PSC. Result 1.0 and up. IR equals relative fuel index, which is the regulator output. The two output signals are Channel 8, 4 to 20 MA analog output signal, Channel 6, VIT alarm output. Load change dependent cylinder lubrication, LCDCL. The LCDCL lubrication is a function that increases cylinder oil lubrication during running with variable load, cylinder temperature. When a certain change in load over a certain time is done, the extra lubrication is activated. Adjustments of this function will not influence the governor. This is a separate function. Parameter 1.84 is the adjustment of the time the change has to last to activate extra lubrication. Increased time value will give less lubrication. Default is 10 seconds. Parameter 1.85 is adjustment of the change in load required to give extra lubrication. 0.10 relative fuel equals 10% fuel. Increased value will give less lubrication. Default is 0.10 relative fuel. Parameter 1.86 is adjustment of the duration for extra lubrication in minutes. If the extra lubrication is activated, it will remain with extra lubrication for this time. Default is 30 minutes. We will now issue the start command from the command handle. Parameter 1.15, speed start setpoint RPM level, defines the speed start setpoint. The regulator will hold this RPM level for the delay time if a start is detected. Start setpoints define the initial fuel setting in pump index during engine startup. Heavy start setpoint, parameter 1.13, is automatically set during heavy start conditions generated in the remote control system. The switches emergency run or cancel limiters can also be used if these switches are connected. Start settings are in pump index scale. Note: if non-linear compensation due to low RPM and the parameter for overriding fuel limiters are both set to true, the pump index is increased while the engine is either stopped or is running slower than the low RPM level. In this case, the fuel rack position will decrease to actual setting when engine RPM picks up. The fuel injected at low speed is reduced by the fuel pump itself and is compensated during start. See non-linear function for more details. Parameter 1.14, fuel start extension time, defines the prolongation of the fixed fuel after stop signal to fuel pump's release. Unit is in seconds. If the speed of the engine is accelerating up to above the setting of the command handle, the extension time is terminated and the governor starts to regulate immediately. Parameter 1.16, speed start setpoint delay time, defines the prolongation of the fixed RPM during start. Unit is in seconds. Default is 6 seconds. This RPM start setpoint will behave in the same way as the bridge control system start setpoint, also when the governor is in control room mode. This start setpoint will not and shall not work together with the QPT function. Note: if the engine does not reach the desired RPM during the fuel start extension time, The regulator will, after 10 seconds, attempt to regulate the engine at the RPM level reached for 6 seconds before handing the engine control over to the command handle.